Hello and welcome to my channel. In this video, we are going to solve problem under heat, optics, and waves. These are different aspects of physics, so we've selectively introduced some problems, calculations under heat and also under waves. So let's see the solution to the first problem on the board. A body emits 60 cycles per second of a progressive wave traveling at 10 meters per second. What is the wavelength of the wave? So let's see the solution to that. And the way we'll go about our physics is we'll make sure we fetch out the parameters given in the equation that will enable us to know what we should be able to substitute into the original expression, or alternatively it can be able to help us to know which formula exactly should we use after we must have fetched out the parameters given in that problem. So a body emits 60 cycles per second. In some book they may say a body emits 60 hertz, and when you see 60 hertz they are talking about frequency. So either you will see it in that phase or in that format, 60 hertz or 60 cycles per second. That is also talking about frequency. So we will have to bring out the parameter that, given that the frequency f is given as 60 cycles per second, cycles per second. All right, which is equivalent to hertz. 1 hertz gives cycle per second. And again, we have a progressive wave traveling at 10 meters per second. In this case, they didn't mention if that is for speed, or if that is for acceleration, or if that is for force or whatever. But saying meter per second alone should introduce to us that that is talking about velocity or speed. All right, so we have v, which is the velocity or the speed at which it travels. We have it as 10 meters per second. All right, we are asked to calculate for the wavelength of the wave, and wavelength has its symbol to be lambda. And you know that there is equation formula that connects the velocity, the frequency, and the wavelength together. So what is that formula? It is v equal to f lambda. All right, so if we are meant to make this lambda, or we're looking for lambda, we have to make it the subject of the relation, and that way we'll be having lambda equal to v divided by frequency. That is, if you divide both sides by the frequency cancels, then you have lambda to be equal to v all over f. So already we have our v to be 10 meters per second, and we have our frequency to be 60 cycles per second. All right, so at this point you can see that 10 into this 0 can cancel out 0, and what we have is 1 divided by 6 meters, and 1 divided by 6 should give us 0.166. I think we have a terminating decimal, so approximately we have 7 here, and the unit for this particular lambda, the unit for this is meters. If you check some of the videos we've dropped already on this lambda, you can see that the lambda is talking about wavelength, which is the distance between two successive crests or trough, and then it is measured in meters. So this is the solution to the first problem. And the second problem here said is coming from heat. This first problem comes from waves, and the topic is always optics and waves. And the second problem we want to solve is coming from heat. We call it heat energy, which is an aspect of a form of energy. All right, we have different forms of energy. Heat energy is one of the forms of energy, and it has a lot in it. So one of the topics in this heat energy is this particular one that has to do with either the ideal gas law or gas law or Charles law, Bohr's law, and all of that. All right, so let's see into this problem. A gas of volume 200 cm cube at 27 degrees Celsius or centigrade is heated at constant pressure to a temperature of 65 degrees Celsius or centigrade. What is its new volume? All right, solution, as we said, the first thing we should do after understanding the equation is to fetch out the parameters. The first volume given, which is V1, is equal to 200 cm cube. Cm cube, you can have volume measured in meter cube, or you can still have volume measured in centimeter cube. And at this particular volume works at this temperature T1, which is 27 degree. And this 27 degree is not up to the standard atmosphere. The standard atmosphere is about 273.15 Kelvin. So that is to say, since it is not up to the standard atmosphere, we have to convert this 27 degrees Celsius to Kelvin temperature. And that way we say that T1 will be equal to 27 degree plus 273.15, all in Kelvin. So that is the conversion rate. So therefore, we have this value T1 to be equal to, if this comes up here, I think we have 300, but let's do that mathematics so that you'll be sure of what we're doing. We have 27. If we sum this up, this will give us 0 because it is 10, carry 1, and then here will also give us 10, carry 1, and we have 3. So you can see that the value we have here will be 300.15 Kelvin. So we've done the conversion, which is very important. The next thing we're going to do here is to continue with the equation. It's heated at a constant pressure to a temperature. We have another temperature, which is T2, and that is 65 degrees Celsius. And you can see this is also not up to the standard atmosphere. And because it is not up to that, we have to convert it to Kelvin temperature, which is 65 plus 273.15. And this is in Kelvin. So T2 will be equal to, hold on 1 minute, let's make sure we fix that problem. All right, welcome back. If you've not subscribed to our channel, please, while you're watching, you can just look down, you see subscription button, click on it and subscribe to our channel, and also click on like our videos, but that will be helpful. So we have 65 plus 273.15, and this will result to 338.15 Kelvin. So the instruction is that we should find, or what is its new volume. That is the V2. The V2 is not given. So how do we calculate for the new volume? Let's take it away and create a space for this. So the new volume is not given, but then at least the parameters has helped us to know exactly what we are expecting. There is a formula that connects both the temperatures and the volume, and that is V1 over T1 equal to V2 over T2. You can handle this in different way, either by making the V2 the subject of the formula, or substituting the value into it, and finally in each of the ways you must always you have to make sure that the V2 is standing alone. So whichever approach you want to give to it, that is fine. All right, so at this point we have V1 to be 200 divided by T1. The final value you have for T1 is 300.15 equal to V2 over the T2 we have is 3. The value there is 338.15. All right. So since we are meant to make the V2 the sum of the formula, we have to cross multiply 200 by 3. That's cross multiplication by 338.15 equal to, we have this 300 again, 0.15 multiplied by V2. So because we want to make the V2 the sum of the formula, V2 will be equal to the product of this 200 multiplied by 338.15, and this will result to 67630 divided by, we have a 300.15. Therefore V2 will be equal to, this will be divided by 300.15, and the result we have is 225.32. The volume is given in centimeter cube. So this is what we are asked to calculate, which is the final or the new volume. Please subscribe to my channel. Thank you for watching, and please click on the subscription button, click on like, share our videos, and please make sure you turn on this notification bell so that when we upload new video you get notified. Thank you very much, and stay subscribed if you've subscribed already.